So next question is a bit different than our questions before. We have to find a and b such that the gradient of parabola anyway, y equal ax squared plus bx and plus 1 at the point 1 and 2 has a gradient of minus 3. When questions asking to find like a, b or any other parameter in equation, basically a question can be also formulated on a different way, like find the equation of parabola in its standard form, given that form like this, that will have a gradient minus 3 at the point 1 and 2. So basically can be questions of that sort can be formulated on a few different ways anyway, but basically the concept is the same whatever formulation is. So we said always when we have to find like a and b or maybe c, d, whatever, we need to set simultaneous equations, as many simultaneous equations as we have to find parameters. In this case, we need two simultaneous equations for a and b, and then solving those two equations we will get solutions for a and b, and that will be our answer. The problem usually comes how to set those equations. Of course, what we know? We have some parabola, and we have one point on that parabola given by coordinates for x1 and for y2. Simply, first equation we can write when we substitute coordinates 1 and 2 for x and y in equation of parabola. So we have y is 2 equal, and now x is 1, squared is 1, multiply a is a, plus here b times 1 is b, and plus 1. So this will be our first equation. Of course, we need one more equation, but we still didn't use the fact that this parabola at that point has gradient of minus 3. Now we will use that information to set another equation. What we have to know here, we have to know that derivative of a function is actually a rule to calculate gradient at any point. But in this question here, we know exactly the point where gradient is minus 3. Then, finding derivative or a rule for gradient of that function, equalizing that gradient with minus 3 for x equal 1 will be second equation. So second equation, we have to find y dash, that is 2ax plus b. So this is a rule for gradient at any point. Now we are using coordinates of the same point, and gradient is minus 3. Substituting 1 for x and minus 3 for y, we will form another equation. And that another equation then will be minus 3 equal, that is that minus 3 equal to a multiply x, x is 1, and plus b. So this is our second equation. Now, really nothing to do anymore with differentiation, simply solving those two equations, we will get values of a and b. Equation 1, if we move 1 on the other side, will be minus 1. So we have a plus b equal 1, equation 1. And from here we have 2a plus b equal minus 3 will be second equation. Anyway, equation is very simple. We can simply substitute whatever equation, let's say 1 from 2. So equation 2 minus equation 1, and we will have 2a minus a is just a equal b minus b is 0, minus 3 and minus 1 is minus 4, and we have value for a. Now to get value for b, it's very simple. Let's say from equation 1 we have b equal 1 minus a, so b equal 1 minus 4, don't make mistake here, because minus a, but a is negative, so b is equal to 5. And shouldn't be a problem with a question like this. Simply full concentration we have to have at the beginning to know exactly how to use this here, and after that everything is easier. Definitely, if you all the time keep in mind when you see a question to find a, b, c, d, whatever, if you keep in mind all the time that you have to set simultaneous equations, and as many simultaneous equations as parameters you have to find, then it will be a bit easier to distribute correctly information for each particular equation, and then will be basically you will come to the stage when just to solve simultaneous equations. So the next question is similar, but here we have some maybe new things to mention. Anyway, we will start with question, and I will explain when we come to that. So we have to find a and c. A and c question mark, such that y equal a x minus 3 power 2 plus 3 and y equal x plus 1 squared minus c can be joined smoothly at x equal 1. First of all, when this terminology join smoothly. What is the meaning when we say that two curves can join smoothly? And what it means smoothly? Smoothly means simply like one continuous curve from those two curves. For example, let's say this curve, and then another curve from here somewhere, but having the same value at that point like the other curve, and let's say going like that. So this means smoothly. Smoothly can't be join them like this, because this is not a smooth point. However, this doesn't mean too much when we have to work questions. This is just for your understanding what smoothly join curve means. But from a mathematical point of view, actually, for practical questions, smoothly means that both curves should have the same derivative at one point, at that point where they are joined smoothly. So that means that this curve and this curve, both of them are parabolas anyway, should have the same gradient of a tangent line at x equal 1. Otherwise, if their gradients are the same at x equal 1, then we can't claim they are smoothly joined. Of course, again, we have to find A and C, so somehow we are looking again for two simultaneous equations, but how to form them? We have here coordinate x, so that is coordinate of one point, but we have to understand that that point is common point for both curves. So the value of y for both curves is the same at x equal 1. If we mark, let's say this by 1 by 2, then at x equal 1 we have y1 equal y2. So that could be our first equation equalizing those two curves. The other equation we can get from the fact that gradients of those two curves must be the same at x equal 1. So we have to differentiate each of those two curves and then to equalize their gradients for x equal 1. To rearrange them little bit, that is y1 equal a x power 2 minus 6a x and plus 9a and plus 3. The other one will be x power 2 plus 2x plus 1 minus c. Now we can find derivatives of each. We have 2ax minus 6a, and derivative of 9a plus 3 is 0 because this is a constant. The other derivative is 2x plus 2, and of course 1 minus c, again derivative is 0. Now if they join smoothly, then their derivatives are the same. So y1 dash equal y2 dash, and from there we have second equation 2a x minus 6a equal to x plus 2. Now we can write those two equations to set like simultaneous equations to solve them. First we will go for this one here, y1 equal y2, but we have to keep in mind for x equal 1. So now we are substituting 1 for x in both equations and we are equalizing them. Anyway, I'll write completely x minus 3 power 2 plus 3 equal x plus 1 power 2 minus c. Now substituting x for 1, and we have 1 minus 3 is minus 2, minus 2 power 2 is positive 4, and we have 4a plus 3, and here 1 plus 1 is 2, 2 power 2 is 4, minus c. And just to rearrange them, 4a plus c equal 1, that will be equation 1. The same we can do here. Again, we have to keep in mind that this is happening only at x equal 1. At that time, at that point, gradients of those two parabolas are the same. So we are substituting x equal 1 for wherever we have x here, and then 2a multiply 1 is 2a minus 6a equal 2 times 1 is 2 plus 2. So the second equation will be, here we have minus 4a equal 4, that will be second equation. Anyway, really, here we already have solution for a, so a equal minus 1, and now to get c, we substitute a equal minus 1 here, so it will be minus 4 plus c equal 1, and c is equal 5. By that we finish this question. Only we have to understand that now we can write full equations of our parabolas will be minus x minus 3 power 2 plus 3, and the other one is x plus 1 power 2, and minus c is minus 5. What is actually a graphical meaning of that? How this looks? We will try here to sketch those two parabolas to see a little bit more clear what here is happening. So this parabola has 3 units to the right, 1, 2, 3 units to the right, and 3 units up. That is a turning point, and turning point is parabola is upside down, what is x minus 3? So the x coordinate here is little bit need to be calculated. Let me check if I have those two graphs here. Yeah, somewhere a little bit over 1 will be here, and roughly that much on the other side. So this is one parabola. That is y1, and the another parabola minus 5 and minus 1, minus 1 and minus 5. It's probably somewhere here 1, 2, 3, 3, 4, 5, somewhere down is turning point, and x equal 1. This is a little bit over, so x equal 1. This parabola 4 is y-intercept, so this parabola going somehow like this. Anyway, it's not really easy on whiteboard to sketch accurate graph. So that is joined smoothly at x equal 1 somewhere here, point. And basically what we will have one graph like this from those two parabolas, and this will be one continuous point. So it's not sharp point, it's just one smooth point, and like we have some new function. Anyway, you don't need to sketch graphs. Question doesn't ask us. In case if you have in your textbooks or anywhere else questions to sketch the graph, it's not a problem to sketch those two parabolas, but it is important to understand the meaning of smoothly joined. What we have next? Next one, the other paper. Yeah, next one is a quite straightforward question. We have to find the equation of the tangent and the normal to the curve. And the equation of the curve is y equal x minus 3 cube roots of x over 2 on 2 at x equal 8. So we have to find the equation of the tangent and the normal to that curve at that point. So I said our question is straightforward, and more on this question to learn maybe to accept somehow this index notation with root, cube root, because most of students prefer fractional powers than cube roots, but anyway that is the same. Sometimes in your questions you may have cube roots or any other root, and then a bit not confident enough anyway, but that is exactly the same. To find the equation of the tangent, we know our concept. We have to start with equation of straight line in its standard form, y equal mx plus c, and this is equation of the tangent to that curve at that point. We have to find gradient and we have to find y-intercept to complete this equation. How to find gradient? Of course, we have curve and we know that gradient is actually a derivative of this function is gradient, is rule for gradient of a tangent line. Then we can write gradient equal y dash of 8. Now we have to differentiate this function, but anyway, it's not really easy to differentiate like this. Now we have to change this notation to fractional power notation and then to differentiate. So we have y equal x minus 3 on 2, and now our cube root of x squared, that is x to the power 2 on 3, and we can find derivative y dash equal derivative of x is 1 minus 3 on 2, but multiply 2 on 3, x to the power 2 on 3 minus 1, and we have 1 minus, anyway this we can cancel, x to the power 2 on 3 minus 3 on 3 is minus 1 on 3. And this is further 1 on x to the power 1 on 3, or 1 minus 1 on cube root of x, that is our derivative. I did here step by step, all steps, just to tell you how to manipulate with those powers. But when you are confident enough, let's say from here straight away to write a derivative, then perfectly fine. Okay, now our gradient is equal, when we substitute x equal 8 in here, and we have 1 minus 1 on cube root of 8, and that is 1 minus 1 on cube root of 8 is 2, and this is half. So our gradient is 1 on 2. To find y-intercept, to find c, then we need y-coordinate. It's not a problem to get y-coordinate because we have our equation and we have value of x to substitute here, and to get value of y at x equal 8. So we have 8 minus 3 on 2 multiply cube root of 8 squared, that is 64, and cube root of 64 is 4, because 4 times 4 16, times 4 is 64. So it's 4 multiply by 4, cancel that, and we have 8 minus 6 equal 2. So now our point has coordinates for x, of course, 8, for y, 2, and substituting those 2 points, in this equation here, and gradient, we will get equation of tangent. We have for y is 2 equal, gradient is half, multiply x, x is 8 plus c. Here 4, on the other side minus 4 plus 2 is minus 2, and c is equal minus 2. And equation of the tangent now is y equal half x minus 2. That is equation of the tangent line to that curve at that point. Now, to find the equation of the normal, we can use everything what we did before. We have gradient of, anyway, I will write here again, y equal, gradient of the normal, x plus c, and my gradient of the normal line is equal minus 1 on gradient of a tangent line, and gradient of a tangent line we have from work before, that is half, and this is minus 2. So minus 2 is gradient of our normal line. Again, we have to find y-intercept, and the same what we did here. For y is 2 equal, gradient is 2, multiply x is 8 plus c, and c is equal, this is minus 16, on the other side is plus 16, and plus 2 is 18. So y equal minus 2x plus 18 is normal, while this here was tangent. So actually it's really straightforward, just to give us more confidence how to find the equation of tangent and normal. So next question is a bit with text, and we know that a daily profit, that small manufacturing company of course depends of number of employees, and can be modeled by the equation. I'm just reading roughly this because you have text. So equation is Pn equal minus n cubed plus 10 n power 2 plus 32 n minus 96. And we have to calculate the number of employees needed for a maximum profit, and we have to find that maximum profit. I mentioned once in previous sessions, then when we have worded questions, always try to visualize a problem that described by that question. So in this case, we are in one manufacturing production area, if you like, where some company, of course, has to make a profit, otherwise it will be closed down. And this equation represents how a profit depends of number of employees. Of course, profit depends of many other parameters, but we are concentrating here to see how a number of people working in that small manufacturing company affects the profit. That means it's not the same if working, let's say, 5 people or 100 people. Of course, 100 people can make much more products, but on the other hand, if that manufacturer can't sell those products, so he can't make a profit, but he has to pay all employees, and he is making no profit, he make loss. On the other hand, if manufacturer can sell, let's say today, 100 parts, but he has only 2 employees, then those 2 employees can't make 100 parts, so he is not making maximum profit anyway. So this equation is actually giving us a relation between profit and a number of employees. Of course, if question of that sort asking for maximum, we have to see a word maximum in our question, and what maximum is maximum profit. So this is profit. We are looking for maximum of that function. That will be our equation that we have to differentiate. We said usually equations are given with 2 or maybe 3 variables, but anyway, this equation doesn't have 2 or 3 variables, it has just 1 variable, so we don't need any extra equation to set to help us to differentiate this equation. We can simply start differentiating straight forward. And dp on dn is equal minus 3n squared plus 20n and plus 32. Maximum profit will be when derivative dp on dn is equal to 0. So all what we have to do, we have to equalize this equation with 0 and to find solutions for n. Minus 3n squared plus 2n, it's not 2n, it's 20n. 20n and plus 32 is equal to 0. We have this quadratic equation. So 3 times 32 is 94. 94, 20, 24 and 4. So minus 3n squared plus 24n minus 4n and plus 32 equal to 0. To factorize this, we can take a common factor of 3 and then here we have 8 minus and from here we can take a common factor 4 plus 4, and we will have 8 minus n equal to 0. We have common factor 8 minus n multiply 3n plus 4 equal to 0, and by null factor law n equal 0 or n equal minus 4 on 3. So our derivative giving us like two stationary points. What I am writing should be 8, not 0. Like we have two stationary points, and we should investigate the nature of those stationary points to see which point is giving us maximum, which point is giving us a minimum. We can do that, it's not a problem, but it will be a problem because wasting time. Here we clear can see which point is giving maximum, which point is giving minimum for that function. First of all, this is cubic function, and that is negative cubic function, and we know that first turning point for negative cubic function is a minimum, while second point is a maximum. So that is one way that we can avoid investigating the nature of those two stationary points, because we are using our previous knowledge about cubic curve. Negative cubic, remember, negative cubic, something like this. So first stationary point is minimum, and this is minus 4 and 3 smaller than 8, but this is maximum. The other way that we can make conclusion which point of those two to take, actually which number to take, simply we always have to keep in mind a reality of those questions. So what we are calculating here? We are calculating the number of employees, so we are calculating actually the number of people. And what this means minus, how number of people can be negative, I don't know, it's unusual. But also even if it's plus, still can't be, because what? We have 1 and 1/3 of people. How? People just 1, we can't be half or third of things like that. So definitely this we should reject, and without any further investigation we have to keep our answer that maximum profit will be with 8 people. So keep in mind again to avoid investigating the nature of stationary points in too many questions, worded questions, because most of questions actually are giving you enough indication that will be just one maximum, or if they are asking for minimum. Sometimes we can use knowledge for graphs from before, but also if we are talking about number of people, number of I don't know, some cows or sheep or whatever, must be the whole number, must be the positive number. So the number of employee is 8, and now to calculate maximum profit, exactly the same what we did before, substituting again here and calculating this. Really, I'm not going to calculate to waste your time. This is just to copy to $8. Simply substituting again here n to the power 3 negative, n squared, and just add those numbers. Instead of that, I think I have some note here. Yeah, I have. Instead of that, I will warn you on one very common mistakes that happening in similar questions like this, and especially when question is asking to sketch the graph. If this question is asking us to sketch the graph, of course this is one cubic curve. I don't know, not to waste time if we can find that intercept or not. I will copy that graph somehow. Maybe somewhere here and a bit closer, and we have that cubic graph somehow like this. You have to be careful because on a vertical axis you have profit. On horizontal axis you have number of people. Of course, profit can be negative. That's not a problem, because if, for example, looking at this graph, 1, 2, 3, 4, 5, 6, this is 8 people. So suppose if you have, let's say, probably 50 people somewhere here, maybe even further, or make it 20, then of course profit will be very, very negative, because the owner has to pay all those people, but they can't make, in that case, profit. The most important number of people on a horizontal axis can't be, let's say, -7, can't be negative. That's why this part of curve you can't show on your work. So must be curve starting from here. Of course, this part can be, this point is included because maybe there are no employees at all, and in that case the owner will have negative profit. So that means if there is no one employee there, owner will occur some losses, because there are some other fixed costs, not just labor, like electricity and any other stuff that has to be paid, even if company doesn't work. For example, rent of premises and things like that. I don't know, there are too many different things. But when here, I think it's number 2. Yeah. When 2 people working, then there is no still profit. he is making money just good enough to pay all fixed costs and to pay those two people. In that case, nothing living for Ovna. For when three people working, then there is a profit, some profit, and that profit rising up to 8 people and reaches maximum to $88 per day. If he employs 9 people that day, then profit coming down and coming down, and if I employ here, I don't know how many I can see. Let me check if I can see better this number. Yeah, it's 12. If he employs 12 people, then again profit is 0. He doesn't make any profit because he has 4 people more than he needed, but of course he has to pay them, and all those money will go on payment for those 4 people. If he continues working with more people, then of course he has to pay all those people. I spent a little bit time on this very simple question, and just to give you a bit idea, I can't say a good understanding, but to give you some idea how to analyze questions of this type when we are working with formula for profit or revenue or this from economics actually part questions, just to have one idea and to avoid some common mistake when rushing to sketch the graph. You have this function, and especially picking your calculator, plotting this function on calculator, and copy whatever you get on calculator without thinking, but there is no mark for that because you miss very important things. We will have in coming exercises, we will have more questions similar. And I think the last question for this exercise, yes, it is the last one. Now we have a rectangular box with square ends. It's to be made, and available cardboard is 2,400 centimeters squared. Find the dimensions of the box for maximum volume. Here, this question is, the same type of question like one before that we did, coming from applications of differentiation, but solving minimum and maximum problems. Once again, like I said before, there is no one established concept for each question in that area. Each question is actually require particular concept, different concept, but some rough idea is, as I said, to read question correctly, to look for words minimum, maximum, largest, smallest, and similar things. Then to set major equation, what that word describes, what quantity that word describes, maximum volume, maximum profit, minimum temperature, or whatever. Usually we said that function is function with 2 or maybe more variables. We had a question before when we saw function with just one variable, but most of questions asking making actually 2 variables. Then we have to go back again to read a question to see which information we didn't use to set our major equation, and to use those information to set another one equation that will give us relation between our variables here, and then to change the major equation in function with one variable, and then to differentiate. So basically this is like one rough idea, rough concept if you like, but as I said, we have to be careful because each question can be different. So we have a rectangular box with square ends. Also, we said whenever we can make some drawing, it will help us. So in this case, we have some box with square ends. I will try here to make it. Oh, probably it's enough. Yeah, something like that. It looks like a box. Square ends, we don't know. Let's say x and x. And length of this box, we will mark it with y. So we have to find dimensions of that box, in this case x and y, but to have maximum volume. Maximum volume. That will be our major equation. That will be equation that we should differentiate later on. Maximum volume. Volume for this box formula is x times x is x squared multiply y. So this is our major equation, and we have to find like stationary point for this function. Of course, we can't do that. We can't do that because we have x and y, and both of them are changing. So both of them are variables, and that's why now we need another one equation to give us a relation between x and y, to give us actually opportunity to express y in terms of x or x in terms of y, and then to replace that variable here and to get function with just one variable. Okay, how to set another equation? We said we have to go back to question to see what else information we have, and to use those informations to set that equation. So here they are telling us that this box is made from cardboard of 2,400 centimeters squared. So we have one piece of cardboard, 2,400 centimeters squared, and cutting this piece of cardboard and folding, we are making that box. Now this number is very important for us to set that equation for relation between x and y. Basically this number is nothing else than total surface area of this box, and the total surface area in this case is 2,400 centimeters. And what we have two of those sides, and area of cardboard to form those two sides is x times x is x squared, but we have two of them, that is 2x squared. Also we have this side and that side, they are the same, but area of them is x multiply y and 2 of them. And finally, we have this top and bottom side, they are the same, and also x multiply y is area of each of them, so another 2xy. This is now our equation that will help us to get here just one variable, because this equation is a relation between x and y. We can fix this equation a bit, so we can cancel by 2 everywhere, and here we have 1200 equal x squared, and xy and xy is plus 2xy. Now, when we discuss how to work with minimum and maximum problems, I said it's usually the same if you express x in terms of y or y in terms of x. However, sometimes that can make some problems in further work. So, which variable here to express in which terms? If we express x in terms of y, we may have some problems, because x is a squared function in terms of y, and more likely we will get two different values of x, and then we may have a problem. Much easier to transpose this equation to make y subject and to express y in terms of x, and then to substitute here and give us better work, easier work. 2xy equal 1200 minus x power 2, and to make y subject, then y equal 1200 divided by 2x is 600 on x, and minus x squared divided by 2x is x on 2. Now we have y in terms of x, and we will substitute that here. Then y equal, I will multiply straight x squared multiply 600 on x, cancel x and x squared, and we have 600 x minus x squared multiply x on 2, we will have x power 3 on 2, and we have volume in terms of x, and now we can differentiate this function without any problems. Then dv on dx equal derivative of this is just 600 minus derivative of x cubed is 3x squared, so will be 3 on 2 x squared. And this is our derivative. To find maximum value, we have to equalize derivative with 0 and to solve this equation for x. So we have 3x squared equal 2 times 6 is 1200, and x squared is 1200 divided by 3 is 400, and square root from 400, x is 20. Again here, square root from 400 is plus minus 20, but we can't talk about minus because we know what x is. X is length of this line here, and how can be negative. So that's why simply doesn't exist that negative number, I'll forget about, and I'll concentrate just on a positive number. So one dimension for x is 20. To get another dimension, we substitute this value of x in that equation to calculate y, and then y equal 600 on 20 minus 20 on 2, y equal 30 minus, this is 10, equal 20 also. Don't forget to write centimeters, and here are centimeters also. So from that amount of cardboard we can make a box that square ends will be 20 by 20, and also this length is 20, and that box will have maximum value. But anyway, what kind of box in that case we would have? Because x is 20, but y is also 20. So in that case we are talking about a cuboid. So it will be one cube, actually, a box that all sides are the same. This is something like when you are looking for a rectangle to have a maximum area, then that rectangle is actually a square. So here also a solid, like we said, rectangular box, but if that box should have a maximum volume, then that box is actually one cube. Let me check if anything else in my notes. You know that would be all for this exercise. We have few more exercises coming in this area. After this exercise, now at least it's quite clear what sort of questions we should try to solve. One thing when we are talking about questions, the type of questions are exactly what you really need on your test and exams, but maybe the level of complexity of questions, here we are going a little bit higher level, and especially when algebra are needed, because we definitely want to improve our algebra, and this is a really perfect opportunity to improve algebra. So basically similar questions you may expect in your homework or test or exams, but a bit easier, a bit less complex algebra. So here a little bit higher algebra, and that's why we are doing this